taking another antiderivative or indefinite integral, however you want to say it, and notice I've added many more formulas, and these are ones that I got out of the textbook that the students that I'm assisting right now are using. I wasn't given these particular formulas with these kx things. I've seen them before. It was actually something that I just kind of figured out using what's called U substitution as a couple of sections later, and just kind of started doing them in my head. But since I gave these to you and they haven't really talked about U substitution, and most of their problems involve using these, I felt like I had to use them. And notice that all the formulas didn't actually fit on here. I'll scroll down a little bit. And there's some more. It's just a couple that didn't make it on there. Actually, just what, one? Anyway, we're not going to use that one with this problem. When we do that problem, I'll scroll down, or I'll just erase some of them. And I don't even know if we're going to use every one of these in these problem sets, but I went ahead and made them, and there they are. So we have the indefinite integral of -5 sine of t with respect to t. So look over here. And I don't have constant times t. Oh, k is a constant, by the way, in these. I should have put that. I think, in fact, you even say that k is a non-zero constant. Yes, k is a non-zero constant in these formulas. So anyway, so we actually, well, I guess you could say k is 1 in this case, in this particular case. So remember, when we do indefinite integrals, we just let that that constant sit there, and then we look over here, and the indefinite integral of the sine of, in this case, 1x dx is -1/1 times the cosine of 1x plus c. So we're going to say that that's negative cosine, oops, I said x, and it should have been t. Let me erase that. What was I going to say about this? Oh, notice that these, you know, basically it's like, well, let's just use that property of bringing that constant out in front really quick. So we have sine of t dt. I mean, this is the question you should always ask yourself when you're taking an indefinite integral or integration, is what function's derivative is the sine of t? Well, the function that has a derivative of the sine of t is the negative cosine of t. So that's actually the thinking process that you use every time, no matter what form you're using. I mean, you might use some kind of rewriting substitutions or you know, different methods in order to get to that point. But that's kind of the question you're always asking yourself. So that's where these formulas come from. So anyway, the function whose derivative is the sine of t is the negative cosine of t. So we'll just clean that up. -5 times negative cosine t is just 5 cosine t, and then plus c. And then we could derive that and get right back to why don't we do that? Check dt of 5 cosine t plus c. That's just a little, I don't want to, well, here, why not? Let's try the erasing tool. Ooh, look at that. So the 5 just kind of sits there. The derivative of cosine t is a negative sine of t. The derivative of c is 0. So just to show you, just to write it the same way, look at that. Check. There you go.